So how are you guys, man?
We're doing pretty well.
Doing pretty well. All right. So who is in US right now? You. So how to
Hi,
pronounce your name?
Itai.
Itai and
Mhm.
Assaf. Should call you Assaf or should I call you?
Yeah, Assaf would be good.
Okay. Okay. All right. So let me get this thing. So I think we're gonna start with some short introduction and what's your daily job all about, and maybe a little bit on your previous talk in hardware.io. I think that is pretty much interesting. Uh-huh.
Yeah, so I'm Assaf, almost 32 years old. I'm from Israel, living in Tel Aviv. So in my current role, I am part of what's called the innovation team at Sentinel One. So we do lots of very different projects, and indeed, in the about last year and a half, I think, me and Itai, we were mostly concentrating on things that are related to UEFI and firmwares on Intel computers and that kind of stuff. And that's how we got to know cheating in the first place. So you wanted to know a little bit more about the talk at Hardware.io, am I right?
Yes, yes, yes.
Yeah, so the talk at Hardware.io, actually, it wasn't really related to cheating, I have to say that. And we also developed some kind of other tool, which is basically like a static vulnerability scanner for
Mm-hmm.
SLM vulnerabilities. So the talk was mostly centered about that tool and also some vulnerabilities that we discovered using it.
Cool. How about you, buddy?
So I'm Itai Liba. I also work for Sentinel One, have been for the past 4 years or a little more than that. Um, Again, in those last year and a half, I've been focused mainly on UEFI, BIOS vulnerability hunting and exploitation. Um, as Asaf said, I actually got to know Chilling through Asaf.
Okay.
He was working on a UEFI emulation based on a project that Pedro, who also used to work for Sentinel One,
Okay.
published. And he thought it's interesting that we might be able to do the same things using Python, which will streamline our work environment and let us do a lot more, a lot quicker. So that's kind of how I got to it. And while Asaf was busy with that, I started working on creating an environment within Chilling for UEFI.
Okay.
That's about it for background.
Okay, it's an interesting project. I mean, when we started chilling, we didn't expect we can go even up to a UEFI level until you guys join in. It's pretty fun. It looks like pretty much whatever you guys created become the de facto standard tools for UEFI emulation. That's a very interesting thing that I mean I got a friend works really deep into a UEFI, and he struggles a lot when it comes to UEFI analysis, and it's kind of interesting, to see a company like Sentinel One. If this is a hardware vendor company, people like HP, Dell, and all these people working on UEFI, that is something that a bit more logical. But people like Sentinel One doing this project, this is something really really awesome. I was from Panda. Spanish antivirus, now bought by WatchGuard, of course. I know lives in an antivirus company. It's not fun at all, you know.
So I think for us it's a bit different because the
Mhm.
innovation team is really free to do what we think is right,
Okay.
and we are not as burdened with contributing to the product as you might think. So we get quite a lot of leeway to work on our own projects, expecting that someday they will pan out to parts of the product, but not immediately. So from that perspective, it was okay for us to work on something that's not necessarily going to get into the product, but at least get us, spread the name of Sentinel-1 a bit further to avenues that it's not used to be shown. And I think it was productive.
Yep. I do understand. I mean, to have the company support on what you like to do and what you want to do right now is kind of fun. That is what we are doing in my current company right now. Whatever things that, oh shit, I shouldn't say this, but I don't think they can watch YouTube in China. So whatever things that I do for in you using the office time, it's pretty much on chilling, and nothing to do with the company. And hopefully, they are hoping someday I will create something that able to help them, which until now not yet.
So we were lucky enough, or at least, yeah, both of us were lucky enough that we were able to push a few projects into the product.
Okay.
So after doing that, they do give us some more leeway with what we can do on company time.
Cool.
Would you agree?
Yeah, definitely. I agree with every word. I mean, we do hope, that at some point in the future, maybe some of the research we conducted around UEFI will eventually evolve into a feature that we can actually push into the product. We had some discussions about that. That still didn't happen, but we do hope that in the future this whole UEFI thing that we did will give some fruit that goes into the product. So yeah.
Cool. So how do you guys actually discovered chilling? I mean, we fucked up quite a fair bit in the early days. The code, everything is so messy, So what brings you there, Such according to Ally, this is a quick and dirty project. That is the reason why chilling starts with a Q.
Yeah, so I'll let Assaf answer how he came to find chilling, but I have some things to say about the messy project.
Yeah. I just today before going online, I listened to the episode with Alien.
Oh my
I know
God.
I heard the reference to the queue in chilling. Yes, so I think Itai already mentioned it. So I was mostly very curious about firmware level stuff and UEFI. But I didn't really have like any background in the subject, and I didn't really know where to begin.
Okay.
Luckily for me, I stumbled across a project that was created by Pedro Vilaca, like I said, and basically it was some kind of a really simple and preliminary emulator for UEFI code. So I think it was created before chilling was created, and it was based mostly on Unicorn Engine, and that's where I got to know Unicorn Engine in the first place.
Okay.
So I started playing it with a little bit. Initially, it was written only for Mac OS X, so I ported it into Windows, and then added like a bunch of different features to it. And at some point, the development cycle was too slow for me because the whole code was written in C, so we had to compile it every time, and debugging was much harder, and it basically took us a lot of time to push this forward. So I started looking, for other projects that are based on Unicorn Engine, and then we got to know Chilling, and I think it was a pretty early stage for Chilling.
Yeah.
But based on the description on the project and the goals of the project, it sounded to us like a good direction to go with, especially the fact that the whole project is written in Python, so that lets us speed things up in the development cycle. So I told Itai about this project, and I think you were quite excited about it. Am I right?
Yeah, I think so. So I wasn't working on the UEFI project at all at the time. It was just Assaf. And I was looking for a project, as one does in an innovation team. You always look for, like, I was between projects. So when Assaf told me about it, I was like, I think I can make it work. I don't know anything about UEFI. I will have to learn on the way. And I don't know about anything about chilling, but to get us back to the conversation about like quick and dirty project, I'm a quick and dirty kind of guy. So I see myself more as a hacker and prototyper than a proper software developer. So from that perspective, I was like, well, I can mash all those things together and it will start to work. And it did. It took like maybe 2 weeks, and we had something running on Chilling. Like we were able to run at least one UEFI module at a time on Chilling with some of the prerequisites. And it took, I think, like another month for it to be stable enough so we can actually use it for Asaf's purposes. Yeah, but I'm not Ellie, and I wouldn't be able to get it to such an organized and nice way, the way it looks in Chilling right now.
Oh my god, his code is amazing.
Right.
Good lord. Yeah. So well, you haven't looked at the really early stage of the code. We started with it was like what, 4 of us. So we started with Unicorn Engine. Okay, we looked through a Unicorn. Of course, I know Quint, the creator of Unicorn Engine personally, like even before he released Capstone. So we know each other way back then. We know each other like what, 2010, 2011. That is where we know each other. And he created Capstone, he created Unicorn Engine. When he created Unicorn Engine, I already told him, we should build something out from it. And you guys most probably know Unicorn Engine didn't really go alive for a long time. The version he kind of update the code when he feels like he wants to update it. Nobody maintained Unicorn Engine code base and all these things, until recently the entire Chilling team kind of joined into a Unicorn Engine team. There's no such thing as Unicorn Engine team, Capstone Engine team, and Keystone Engine team. Keystone Engine team, Unicorn Engine team, and Capstone Engine team is one guy. So there's no team. There's only one guy, and that's it. So a few of us decided, we should make that 3 project alive together with Chilling, because Chilling heavily rely on that project. And when we started, we discovered quite a fair bit of bugs, like some ARM code didn't work, some ARM register didn't work, some MIPS register didn't work. And this is how the quick and dirty comes about. Each of us writes an OS. So I wrote Linux, the other guy wrote Windows, and one more guy wrote Mac. And when we have a Hello World running, we only plan to run Hello World, that's it, nothing else. So we write a hello world code, we compile it, and then we wrote the loader, make sure it works, and then together with the libc, together with the kernel extension, together with Windows DLL. When hello world works, that is where we sit down and we were like, how the fuck we can join these three things together? Because we never talk to each other when we write these three codes. Everybody write their own style, and we try to merge it, and the other guy comes in like, okay, now we need to turn this into framework. And Quinn comes in. Quinn was like, okay, I got some idea. So he got a little bit input. We changed a little bit, and then whenever we patch everything up, we did patch everything up, and that is where we release version 1. 0.1 or version 1 or whatever version we call it. 2019 in St. Petersburg, 09. That is where when, back then during conference RAIL, everybody can go to real conference. Except Hardware IO recently, you went to a proper conference. So you went to India, or it was in Israel, the conference? Hardware.
It was in the Netherlands.
Okay. All right. Use case. So things that I always wanted to ask. You guys have any very specific use case when using chilling with the UEFI module, or any specific bugs that you guys discovered along the way?
Yeah, so I think, I think, do you want to answer it? I think you have like the better perspective for it.
I do, but I was hoping for you to talk about EFI fuzz before I'm talking about my own adventures.
You can show the EFI fuzz right now if you want, or you can show whichever demo that you have.
No, I think I just can talk about EFI fuzz like Itai suggested.
Okay.
Yes. So initially, our goal was to eventually be able to fuzz UEFI code and hopefully discover some vulnerabilities, get some CVEs, that kind of stuff. So we started like our own project on top of chilling that we call the EFI fuzz. It's already public on GitHub. And
I should do this thing like, link down over here.
Link in the doobly-doo.
All right, continuing.
Yeah. So then we basically like started committing code to EFI fuzz and chilling in parallel, you can say that. I think that eventually most of the big features that were kind of merged into EFI fuzz were also at some point ported to chilling. So in its current form, I don't think that EFI fuzz has a lot to offer in addition to what chilling is already offering. So I think that the main attack vector that we tried to exploit in EFI fuzz was initially what's called environment variables. These are basically like configuration settings of the BIOS.
Okay.
And also we wanted to be able, that was I think a bit unrealistic on our side, but maybe that's understandable because we both didn't came from a UEFI background, and we made some mistakes along the way. Initially, we wanted to be able to emulate the entire BIOS of the machine. So we wanted that you can dump the entire BIOS on your machine and then just feed it into EFI fuzz, and it will, automatically load all the modules and emulate all the code and fuzz everything, and then find some bugs. I think that as we made progress, we slowly began to realize that this might not be so realistic, because firmware emulation has a lot of all these nitty-gritty details that you have to take care of, and of course there is eventually the the issues of actually interacting with the hardware, which is always hard to emulate. So I think we did make, you know, some like design mistakes, I would call it that way, that we did when we developed the EFI fuzz. But still, I think, you know, this work definitely was worth the effort, for two reasons. So I think that the first one is that we actually learned a lot from doing it, and I would even say, you know, that the best way to learn like a new technology is to write an emulator for it. And the second one is that even though, you know, the fuzzing part maybe wasn't that fruitful, still the ability that we have to trace through UEFI code and to emulate it is a really powerful tool that we currently have at our disposal. And Itai may be able to elaborate on it a little more. But basically, every time that we found that we discovered a vulnerability, you know, by doing some other kind of using some other kind of tools, or maybe doing some static analysis, then we could also emulate the code dynamically, and, you know, convince ourselves that that actually this is a bug, or maybe we found out that no, it might look like a bug statically, but dynamically we can see that this flow, for example, will never be taken, or something like that. Yeah, Itai, would you like to elaborate a bit?
I will jump in, and first I'll talk about the EFI files. While Assaf was working on EFI files, I was trying to complete what he just said about like loading the entire ROM to chilling, and I did get to quite an advanced stage. Again, it wasn't the right way to go, but it was interesting, and it's also interesting to know how far chilling was able to go. So I think I was able to, I had a script that loaded like a specific ROM. It loaded 240 modules in parallel, like 240 UEFI DLLs, or executable modules, in parallel, and they all ran and did their main, and one would call functions call from the other. So as far as chilling was able to take, it was quite a lot. It did take something like 10 minutes to run, but still it was pretty impressive as far as chilling was done. And also it got me to look into, I knew that Assaf would like to take that loaded ROM and start fuzzing it. So I looked into ways to help. So chilling has a save state kind of functionality, right? So we took that into account, that instead of running those all like DLL mains, module entry, executables, whatever, one after one, and doing all that round robin of loading all the modules, we will do it once for per ROM, save a state, and then we can fuzz on top of that save state. And I think we kind of almost got it to run, which is okay. That script also helped when Ellie got into the project and started to do like major changes. So I was able to take the same script and tell him, you know, Ellie, you just broke something. You broke that. Can you fix it? And so at first, when he did the first iterations, because I had so many UEFI modules running at the press of execution of a script, I was able to like catch him multiple times and tell him, oh, you broke something of mine, you broke something of mine. And then we were able to like get into a working state with his like beautiful code, but without losing any of the functionality we had before. So that's that. Since then, I didn't touch chilling for quite a long time. And recently, I wanted to, I was working on exploitation of a UEFI vulnerability.
Okay.
and got to a stage when when I have like a quite complicated rope, and I couldn't debug it on the machine. It was just too much. There's no output when you are running code in
Yeah,
UEFI, of course.
of course, yeah. There's no
So
calculator.
I was talking to Assaf, and Assaf was like, "Can't you just emulate it?" And I was like, "Yeah, but I will have to write it all on chilling and like do it now." But still, I was like, "Okay, I'll take it into consideration."
Mm-hmm.
So it took me, I think, 2 hours to port all my code to chilling,
Mm-hmm.
and then I was able to debug the rope even without going into all what we used to do when we try to emulate everything with chilling. Now I only wanted this single function to work, so I was able to load like just two modules. I didn't even run the module's main function. I jumped immediately into the function I wanted to debug, and I as my rope chain grew, I had to add more and more modules. And at one point, I also got like a memory dump from the machine and like patched
Okay.
the already initialized data segments for all the modules directly into like using just chilling mem right.
Mm-hmm.
I patched all the memory to its place, and then I was able to debug just or to emulate just that one function with all the rope chain, and found like multiple problems in the rope chain and fixed it, and like took that ready chain to a real machine, and it just worked. So
Cool.
from that perspective, chilling was great for me.
Cool. I didn't expect that to happen. I was expecting you say that you need to spend like another 2 days to fix the rope to run it actually.
No, after it
Amazing.
worked, I was able to. I kept the same kind of like Python code between the real machine and chilling, like
Mm-hmm.
same name, same everything, and I was able to take the rope chain back and forth, and it just worked.
Nice, nice. So you guys actually found some 0 day some UEFI 0 day using chilling using EFI fast.
I don't think we did, but
Yeah, so I think for most of the vulnerabilities we discovered
Mm-hmm.
actually came from the other tool. It's
Okay.
called Brick.
Yeah,
So
I
it's
saw that.
like
Mm-hmm. Yeah, link down
it,
below.
it, yeah. So in some ways you can think of it like as it complements chilling. I think you can say that.
Okay.
So chilling is all about dynamic emulation and that kind of stuff. And Brick is like entirely static vulnerability scanner, which is based on IDA. But I think that, in many cases, the workflow we've been following is that we run Brick on some kind of a UEFI ROM. We get this report file that pinpoints what the potential vulnerabilities are. And in some cases where we're not, 100% sure if it's a true positive or a false positive, then we try, to emulate a potentially vulnerable function and see if we can indeed, trigger some kind of a memory corruption or other kind of primitive that benefits us. So in many ways, you can say that these two projects like play together really nicely.
Cool, cool, cool. Yeah, I will definitely put a link down below. It's not a lie. uh, so recently we added MCU. Wow.
excuse me.
Recently we added the MCU. So specifically STM32 series, F1, F4, F7. So the Cortex M series, that is what we added in, and we added in RISC-V. So RISC-V, the MCU module, and RISC-V as a OS.
Oh, the OS
So
too.
yeah, so if you guys are interested, always welcome to take a look. And one of the guy from Qihu 360, a Chinese-based security company, they added in a U-boot. So now we are able to emulate more or less U-boot on a shilling. So that is kind of another fun project, you know. So we are a bit more hardware right now, a little bit more.
Yeah, that plays more to my afternoon time than my work time.
Okay, Asaf, do you have any demo that you would like to show us?
Yes, I think I sent you the video.
All right. So I just use
Do
the
you
video.
want to play it?
Mm-hmm. So I will just add in the video into the I will add in that video into this video. So yeah.
Yeah, so do you want me to elaborate a bit on what's going on there?
Yes. Why not? So it's like two video or three video, two video.
I
Yep.
think you
So
sent the same
Yeah.
one twice,
the same
right?
one twice.
Oh, yeah. It's probably the same one that's been sent twice.
Okay. So how do we do this? You want to play the video? Okay. If you play the video, it's gonna be blur, I think. So yeah, you can talk a little bit on the video, and then I will attach into this video later on.
Yeah, okay. So basically, I think it's like a common pitfall that you see a lot in UEFI code is that uh, basically the code wants to update the contents of some environment variable. So it first fetches the contents of the variable from NVRAM into some kind of a local stack buffer, and then it does all the modifications, and then the code writes back the modified stack buffer into NVRAM.
Okay.
But the pitfall is that sometimes the stack buffer is not initialized to anything, so it just holds contents from previous invocations and that kind of stuff. And also that the contents of environment variables can be controlled by attackers that are running with lower privileges than the privileges that the firm requires. So that means the attacker can trim the variable to make it shorter, and then when the code fetches the variable into the local stack buffer, a large portion of the buffer would still be uninitialized. And when the code writes back the variable to NVRAM, it doesn't really take into account the actual size of the variable. It just, in many cases, just uses the hard-coded size of the variable that the programmer assumed is correct. And so by doing it, basically the code writes back a large chunk of uninitialized memory into NVRAM, and these NVRAM variables can also be queried by attackers. So basically that's an information disclosure vulnerability. And if you, for example, think of SMM modules, that would mean leaking out the contents of SMRAM code and data, and that's basically breaking a really important security barrier. So in the demo that I sent you, we basically use chilling in order to poison the stack with these canary bytes. And we actually emulate this vulnerable function, and you can actually see that after emulating all the code, the content that is being written back to NVRAM holds all these canary bytes that were taken from the stack. So that's actually pretty impressive in my opinion. It really likes demonstrating the use case of how to exploit this kind of issues.
Okay, now we got another issue. I tried to download the video. I think you need to drop me an email or Google Drive link or whatever for the video. It doesn't seems like I can download from Twitter.
Okay, I'll send
Sure,
you.
sure.
I'll send an email.
All right, buddy. I try not to hold you guys for too long. It's still a early Sunday morning for you, and I think pretty much Asaf, you are like what, afternoon, evening?
Afternoon.
Okay. So thank you very much. Thank you for your time, guys.
Thank you.
Thanks for having
Good.
us.
Yep. So hopefully we can do this again
Sure.
to promote your
Sure.
next project, maybe.
We'll see where work takes us and how much time we have.
Sure. All right, man. Thanks for your time. Appreciate it. All right. Okay. Bye.
Bye. Thank you.
Bye.
Bye.